Well, thank you. I'm going to use the microphone, but I can talk pretty loudly too. So, and the clicker is gone from here, so I'll have to go back and forth. But so bear with me on that one. I've become a trialist over the years. I started my career largely doing observational studies, and fairly quickly became convinced that the trials were really the gold standard in terms of really understanding causality as much as we can understand it. But now I feel like we're sort of slipping back a little bit with these sort of step-wedge designs. So I thought it would be an interesting opportunity to sort of talk about some of the struggles we've had with analyzing this data and why I like the standard randomized trial better. Although I was driving into work this morning with Scott Ziegler, and we were having this conversation about, because he's been working on the analysis of this, and he was saying, I don't know why are you complaining about this? These are great trials, and this is an interesting design, and you can answer all these sorts of questions with it. And so we're in some disagreement about this, but I'm going to present my perspective on this today. So with that, I want to just say a little bit about indoor air pollution and sort of where the field stands right now, to give you a perspective on why we decided to do this trial. There's been actually a lot of information about indoor air pollution and the use of burning biomass in cookstoves, which is done a lot all over the world. And China's a good example, but they mostly burn coal. But in places like South Asia, they're mostly burning wood, dung, other crop waste, things like that. And this produces a tremendous amount of particulate matter, and mostly in confined homes. And there's been a lot of work on the global disease burden of this, and people think that it's attributed, that about 3.5 million deaths are attributed to this annually, and about 4.3% of the deaths as of 2010 were associated with indoor air pollution. These are mostly all coming out of observational work. There's been one randomized trial done to date that looked at an improved cookstove design, still using biomass fuel, but an improved design that reduces the indoor air pollution. And that was done in Guatemala, highlands of Guatemala. Kirk Smith at Berkeley is the person who, for many, many years, was trying to get money to do a randomized trial of this, and eventually did get that. The results are somewhat equivocal for respiratory illness. It seemed to have some benefit for very severe respiratory illness in kids, but not sort of their primary outcomes. And then there have been lots of observational studies, but they have tremendous confounding, and it's difficult to know how to really adjust out all of that. We proposed to do a randomized trial in Nepal, which also has a lot of indoor air pollution, and took us many backs and forth with NIH, and eventually they did fund us, the National Institute for Environmental Health, and then we were able to get a little bit of additional funding from the Thrasher Research Fund to look at pregnancy outcomes that might be associated with indoor air pollution. So stillbirths, low birth weight, preterm birth. And then a little later in the study, the Global Alliance for Clean Cookstoves, which is a UNICEF foundation, put in some money for a second phase of this trial, which was actually a standard randomized trial looking at liquid propane gas stoves versus the improved biomass stove. And I'll say a little bit more about that. So Nepal is a small country, about 28 million people, that's wedged between China and India. And so this is Kathmandu, the capital, and this is our field site, Saralahi district, which is on the border with Bihar. And so usually, you can kind of see this really nice photo, which I can see better here, that people think of nice mountains. Let's see if we can, because I've got some nice photos and they may not come up. Oh, that's better, yeah. People think of these lovely mountains when you think of Nepal, but in fact, not very many people live there. And this is mostly where people live. And what you can see is sort of villages that are tightly packed, surrounded by farmland. And this actually has some implications with regard to the indoor air pollution, because the houses are very tightly packed, which is sort of part of the idea of cluster randomizing these sorts of studies. So this is the basic design, and I'm going to say something about why we picked this design, although I'm not really sure why that was a good rationale. But we actually felt, the reason we did this is we felt it would be very difficult to randomize people to get an improved Cookstove or not, that people who felt that they were not getting the stove would not want to participate. And that the stove would be desirable in the sense of and that people would not. So it was more of a political reason than anything else. And we felt like, okay, if we could say to people, you will get this stove, we're rolling this out, you'll get it at some point, and we'll randomize when you get it. So we thought that sort of that would be the most acceptable to the population. And I think that was really our primary reason for doing this. Other people have lots of other reasons for doing step-wedge designs. This was our rationale. So we had, the design that we had was, we had 12 groups that were going to be randomized in terms of the timing of the intervention. And we built in, which most step-wedge trials do not do, is a 6-month surveillance prior to doing any interventions, and then a 6 months at the end where everybody had the intervention. And these were balanced in terms of seasonality. And then what we did is, starting in the 7th month, we stepped in the intervention 1 month at a time, until after 12 months, everybody had the intervention. And so this is the intervention months here, and these E's are the environmental exposure measures that we took. So everybody got a pre and a post environmental measurement, and we designed it so, it wasn't perfect, but we designed it so that it would be roughly the same amount of time pre and post the intervention when they got the measurement. So that's the basic design. And then just to say a little bit about the kind of analysis that you might do, if you look across the rows, what you see is sort of pre and post for any individuals, right? So that's one kind of analysis that you could do. That's potentially confounded by a time trend, right? And then if you look at any point in time, you're sort of looking cross-sectionally, and some people have the intervention and others don't. So that's the one that's not time confounded. And then the question is how to kind of combine those two types of measurements into something that makes sense. So that's the idea. So we did this whole trial, and one of the things that we saw, and I'll show you some of the data, is that the environmental exposure, these stoves that we put into people's homes, did reduce the indoor air pollution substantially, but not nearly enough relative to, for example, the WHO standard for indoor air pollution. And so we were originally going to do 2 of these stepped wedge designs sequentially, and because we felt we couldn't do as many, that we couldn't do the sample size in one go. So we sort of had, we do the one trial, and then we were going to go and do the second version and combine them. But when we got to the end of this and we saw the fact that these stoves really didn't reduce the indoor air pollution adequately, we changed our design, and we did, the second phase was a standard randomized trial where we randomized households to get a liquid propane gas stove versus keep the improved biomass stove. And then we just followed them for a year. And what we did is we built into that budget that everybody would get a liquid propane gas stove at the end of that study. And that was our sort of aim, was to make it a palatable trial to be randomized to. So we sort of said, if you aren't randomized to get the LPG stove, you'll get it at the end of the trial. And that seemed to be actually quite acceptable. So I think this thing of worrying about, whether people would participate we probably didn't have to worry about it if we had built in that everybody would get something at the end. So that was the second part of the study and the aim of doing that was to get ourselves further down the dose response curve. And actually it was kind of prescient, because for people who know the indoor air pollution field, there was a lot of sort of interest and expectation about these improved biomass stoves. But I think what people are thinking now is it's not going to do it for health outcomes. And so there's a lot of more interest in clean stoves of some kind, clean fuel of some kind. And so actually the second phase is helpful in that regard. Yeah. Are the people who had the improved biomass stove. So this is a subset of these people. Yeah. So everybody eventually gets the improved biomass stove, and then we took a subset of these people, randomized them to either keep the stove or get a liquid gas stove. And I have to say the liquid gas stove everybody wanted. We also provided the gas free of charge for the year. So that was a huge thing, because actually this is more of an efficacy part of this study, because this is too expensive an intervention for a place like Nepal. Whereas these stoves are about $27 a piece. So they actually are potentially affordable. This is not an affordable mechanism. And I'll tell you a little bit more about sort of what happened to all these stoves at the end of the study. But one of the things in going around villages now and asking people, are you still using the stove? What do you like about it? Not, and so on. They all like the liquid gas stove, but they actually can't afford the gas. So now that the trial is over, they're keeping it, and I think probably occasionally when they have money, they'll buy gas, but mostly they actually can't use it. So the way in which we tried to design this study was, these are the 12 groups of sort of clusters that were randomized in terms of timing of intervention. And then what we did is, if you look at, for example, the group 12, this pink one, we tried to make that group several clusters that were sort of geographically spread out. And then within the cluster, there were a bunch of households together. So that was the design. And we were trying to kind of separate out the effect that randomizing a cluster of households to these improved stoves might have sort of on the broader environment. So that was the aim of this design. When you actually get to doing these things and trying to implement them, things get a little more complicated. So the idea was that we were going to implement these stoves over a 12-month period, and each month we would do one of the cluster groups. And this is the timing of when the stoves were introduced. And you can see that mostly we kept to about a month, but there are time periods where, so for example, this group 10, where it took us a lot longer to implement those stoves. And this coincides with a whole series of Hindu holidays that take place around sort of October, November. And so there were lots of time periods where our staff were not working and so on. And the reason I show you this is because if you think about this kind of trial design and you now think, what's an intention to treat versus a per protocol analysis, it gets very complicated. I see Larry nodding his head because he's done one of these step-wedge trials. It's very difficult to say what was the intention in terms of the randomization, because the intention was this was the month that they got it, and sort of on average, you'd expect people to get their stove halfway through the month. So what we've thought about in terms of this is to say, if the date of your stove installation was within this 1 month time period that you were intended to get it, you're in the intention to treat. If you fall outside, which you can see, there's a whole series of households here that fall outside the range, the time range, when you're trying to say what's the, so in the per protocol analysis, we would move you back and pretend like you got the intervention when you were supposed to. In the intention to treat, we just say whenever you got the stove, before after thing. But it makes that kind of analysis a little more complicated. Okay, so the eligibility criteria for the first phase of the study was, and this really applied to most people, they didn't have an improved stove, and they had a house that had at least 3 walls enclosing this traditional stove. And I'll show you some photos of what these stoves look like. And the idea there was there are people who have these stoves and use them outdoors. And that's not so interesting to us. I mean, it is of interest, but in terms of sort of understanding the indoor air pollution. And then we have some houses that have walls made of thatch or bamboo, and we had concerns about fire safety implementing these stoves in that kind of household. So we did not include them. And then, of course, they had to consent, and, we wanted them, obviously people do or don't, to use that, at least agree up front to use the new stove for at least 12 months. We did not take out the traditional stove. We just put in the new one. So they had both options available to them. And then the households in which we did this were ones where there was a married woman between age 15 and 30 years, or at least one child that was under 36 months of age. And the reason we did that is we were looking for pregnancy outcomes, or we were looking for respiratory illness in the young kids. So, and then in the second phase, we took 2 of the 4 original study sort of geographic areas, and they had participated in phase 1 and continued to have this age group of women. We lowered the age group of the kids in the second phase because that's the age group that has the highest risk of respiratory illness. And then, or we could add in new households that had these types of participants. Again, consent to be randomized to keep the current stove or get a gas stove. Yeah.
Is there a reason why limiting women to under 30 years old? I was thinking a lot of they became very tired.
Yeah. So it was arbitrary, but it was thinking about sort of the age range where where people are more likely to have lots of kids. So it was just sort of like how many people do you enroll versus how many people are at risk kind of calculation. But it was an arbitrary thing. Usually when we do sort of these trials with pregnancy outcomes, we include people up to 49 years of age, but given how difficult it was to implement all this and the number of stoves and what they cost and so on, we tried to limit it to the highest risk, yeah.
You may be getting to this, but can you say something about the mobility of the population, so the people moving around?
Yeah, so there definitely is movement. It's not a very mobile population. It's a rural area. But actually the biggest movement of population are particularly first-time pregnancies. Women will often go to their parents' home to deliver the child. So something like 5 to 10% of the pregnancies, people will move house halfway through the pregnancy. Actually, I'm not even going to talk about the pregnancy outcomes here. That's even more complicated because you've got pregnancies that have part of their time period before the stove and part after the stove, and which parts, is it the third trimester that matters, or so that sort of whole timing of when you're exposed to what in pregnancies, a whole nother sort of issue in terms of analysis. But I'm thinking about that part, but I haven't got there yet. Okay, and then as I mentioned, all the participants would get the gas stove at the end of the study. And that was not trivial in terms of budget, actually. So that limited our sample size in order to be able to do that. But we felt that we wouldn't get the participation if we didn't do that. Okay, so let's see if I can turn this thing off here. On the left. Ooh. No, but that doesn't help this one. Yeah.
Like the third down on the left.
Third down on left. Ah.
Yeah.
There we go. Okay. So this is just to give you an idea of what the traditional stove looks like. So it's a mud brick stove, and it has a firebox, and then they've built up with the mud places for the pots to sit. And then here's one that's in operation, and you can kind of really see how much smoke is being emitted by these stoves. And what you can also see is these are all women sitting there all day toiling over these things. And so they're the highest risk people.
Are there more than one in a kitchen? It looks like there might be two there.
Yeah, sometimes there are. It depends on the kitchen. And there's a lot of variation in how these are used as well. So sometimes in summertime people might cook outdoors, and they have sort of little portable mud ones that they use outdoors. So we actually went weekly to do sort of compliance assessments, but I haven't even gotten to what that all looks like. But it's a behavioral thing, so there's a lot to do with what the compliance is like. Okay, let me go back here. So this is the new stove. So it's still a biomass stove. You can see wood here. It has 2 burners, and the design of this is such that it sort of pulls the smoke up and out through the chimney. And so the chimney is sort of the other part of this that really reduces the indoor air pollution. Of course, what you're doing is reducing the indoor air pollution, but you're venting it to the outside, which is a whole another part of the story. And this is what it looks like on the outside. So you can see that this is not actually trivial to implement, because you have to make a hole in the wall and you have to put the chimney up and so on and so forth. But this is what it looks like when it's venting to the outside. And it's not a perfect design, because when the wind is blowing a certain direction, the smoke will come back in and so on. So anyway, it's as best you can do. And then these are the liquid gas stoves. They're just like a countertop stove and attached to gas, and people have to buy the gas. But we provided the gas on a monthly basis to them. Okay, so now I'll see if I can get all this back on again. That's pretty good, yeah. Okay. So the primary outcomes for us were incidents of acute lower respiratory illness in these children under 36 months of age. And it was a sort of an open cohort, so births moved in and kids moved out at 36 months of age. And our primary outcome was a fever and difficulty breathing on at least 1 day, separated by at least 7 days symptom-free. But we collected weekly morbidity data by recall of the parent on a variety of symptoms. So we can modify this outcome, but this was sort of our primary outcome. And then for severe respiratory illness, the same definition, but an elevated respiratory rate or chest retractions or unconsciousness. And this was aiming to get at more of a pneumonia rather than trying to take out the upper respiratory illness. And then birth weight and gestational age were the other two outcomes. And then we had a whole series of secondary outcomes, forced expiratory volume, respiratory symptoms in adult females, blood pressure, pulse, oxygen saturation, and then the measures of environmental exposure, which are particulate matter 2.5 and carbon monoxide. And the way in which we did these measurements were basically, we have monitors that take measurements every 10 seconds and we put up these monitors for about an 18-hour period in the household. And we did that pre and we did that post. And then we also logged temperature and humidity, because I don't want to go into all the details of these environmental exposure measures, but you need to adjust for temperature and humidity as part of those measurements. So this is what the particulate matter logger looks like, and we suspended it sort of above the stove, roughly at this sort of distance, and it was put up in the household and remained there for about 18 hours was our intention, and then we took it down. This is the temperature and humidity logger, and then we sort of had a bag with all this equipment, and we hung it up in the household, came back later and retrieved it, and then there was a whole process of downloading this electronic data, the temperature, the humidity, the PM, the CO. We always joke that we didn't want Homeland Security to come and see any of these pictures. They look like very harmful things that we were doing. Okay, so now I can actually show you some data. So up here is the PM concentration data by hours in the day. And what you see here is you have relatively low levels of exposure except at 2 time periods in the day. And these are the cooking episodes. So around here is the breakfast meal, and here is the evening meal. In Nepal, in general, people do not cook for lunch. So this kind of fits very much what we would have expected. And then the CO measurements follow a similar pattern. There's a little bit of a lag in the CO measurements, kind of lag the PM concentration measures. But this gives you a sense of what's happening on a daily basis in terms of the exposures. So you have these sort of huge upswings in exposure during the time period that people are cooking. And which got us into sort of, well, what is the right measurement here? Is it sort of your average daily exposure, or is it the average exposure above a certain level or for a certain number of hours in the day? And we're sort of trying a lot of these different measures now as different indicators of exposure. But I don't think we have a good sense, and I'm sort of looking at Sat, who's the environmental person here. I don't think we have very good sort of ideas about what types of measures are actually the ones that have the health impact. So, I think that's still a lot of work that can be done. In terms of seasonality of these measures, you can see that there's quite a lot of seasonality of the PM measurements as well. And I mention all of this because when you do these stepped wedge designs, you've got things changing over time. So you have to deal with the seasonality in thinking about these exposures. So this is the monsoon season, and during that time period, you have the lowest PM exposure on average. And the CO exposures are not nearly as seasonal. There is variation, but not, and they don't sort of tend to follow in quite the same way that the PM exposures do. And then just to get a sense of how the humidity and the temperature are affecting this. So this is the humidity, and you see in monsoon that's pretty high. But it's also very high in January, which is a time period when there's a lot of fog that settles over all of North India and northern South Asia. And then similarly, the temperature is very high. You can see it's sort of in the 90s during a large portion of the year, and it can get down into the 50s in the winter. Yeah.
What's the sample size we're looking at?
So this is about 3,000 households. And, you know, there were some issues with the measurement. You have all sorts of interesting things happen. You have, like, bugs that crawl into this device and, you know, you can't actually use the measurement and so on and so forth. But it's roughly 3,000 households in which we have pre- and post- exposure measurements. Okay, and then just to give you a sense of the variation in the PM concentration exposures, you go from about 50 all the way up to about 2,000, which is huge, absolutely huge. And similarly for the CO measurements. So these are exposures that are like way, way, way beyond what EPA or WHO requires in terms of standards. So just to give you a little bit of a sense of the pre- and post-installation PM measurements, this is the distribution pre-installation. You can see, first of all, they're not normally distributed. You do have some improvement post-installation, but you still have very high exposures in the post-installation period. And if you look at the WHO standard for exposure is 25 micrograms per cubic meter. And if you look here at the average, it's about 1,300 or so. And here it's, you know, it's not much less, right? So, you know, that's very disappointing to us in terms of what these exposures, what these interventions did for the exposure, at least. And that's why we went to that second phase with the liquid gas stoves. Okay, so here is a plot of the incidence, monthly incidence of acute lower respiratory infection in kids. And you can see this pre-installation period, and then there's post-installation. So there's this period in between where some people are pre, some people are post, and then here's all the post-installation. And what you can see is you've got a downward trend in the pre-installation time period, and then you have this overlapping exposure, and then you have what appears to be at least less variability, but I'm not sure what that really all means in the post period. So this is what, to me, makes this kind of data very complicated to analyze, because these trials really this design really relies on not having a secular trend. And there's both, you can actually see the seasonality of respiratory infection. So there are periods where it's high, periods where it goes down, goes up again. So you have the seasonality, and then you have these trends over time as well. Okay, so this is the regression model that we've sort of settled on to try to examine the impact of these stoves on respiratory infection. So the primary outcome is the respiratory illness episode, and then we have an indicator for for the stove installation, and then we also add sex in there, and then we try to detrend the data by putting cubic splines along the data in terms of calendar time, and then we also put the age of the child in and use splines there as well. So what you see here is about a 30% reduction or so, 26% reduction in the incidence of acute lower respiratory infection in these infants that could be attributed to the stove installation. And actually, we're pretty pleased with that, because Given how much less the indoor air pollution improved than what we had expected, we're quite pleased with that outcome. In order to look at sort of the validity of the detrending, we took these splines every 200 days, 150, 100, and so on. And what you see is that it doesn't really affect the coefficient, the regression coefficient, very much. So we felt fairly comfortable about picking one of these and going with that. So this is kind of our basic model now that we're going to use for the analysis. And so here's just to show you the predicted values when you use calendar time in months. You use an indicator for each month. And you can see this overlap time period. It's a little difficult to see that 26% reduction when you look at it this way. But if you look at if you look at it using the splines and you've smoothed it out a lot more, you can kind of see here's the reduction basically. So yeah, Larry.
So this shows what we saw in the first design slide. Is that it's very unusual stepped wedge in that you don't have control comparison time all the time through the wedging. So half the time you have no contemporaneous control, right?
Yeah, at the beginning and at the end we have no controls. Yeah.
That's half the time there's no control.
Right.
I'm trying to interpret these coefficients because it seems like any dummy variable for those monthly is then completely depends on the convention and control. And there's no control. Any dummy that's attached to a month is giving the contrast between intervention and control. I mean, it's in spline.
Yeah, so that's where it's drawing its strength from, right? That's where the analysis, that's where the estimate is coming from. I mean, you're making assumptions, obviously, right? I mean, this is partly what I don't like about this whole design, is I feel it's uncomfortable to me. I'm worried about the models and whether the models are correctly specified, right? Right. Yeah, I mean, this worries me, right? This is why I don't like these designs very much. I mean, it's interesting because in my conversations with Scott, he's much more comfortable with this than I am. And I've sort of realized I've become an epidemiologist rather than a statistician. Because I don't feel like everything can be resolved with statistics, or at least I feel like it's important to be able to explain and have it be clear to non-statisticians what's happening. And to me, part of the sort of standard randomized trial is being able to do that. But, I don't know. I'm still thinking this all through. Okay, so what I wanted to just end with was sort of what my concerns are with this kind of design. So clearly when you have secular trends, and obviously the longer your trial takes, the more likely you are to fall foul of this. It makes all these inferences much more complicated than the standard randomized trial. This whole issue of sort of the timing of the intervention and how do you do this intention to treat versus per protocol analysis. I mean, I think you can come up with something, but it's a lot more complicated than what you would think of for a standard trial. And then, I think there are ways to do this, but, I think there are more different possibilities about how do you combine this kind of pre-post within-person analysis versus the cross-sectional analysis. And actually, so Scott has some methods now where he can actually take this data and kind of see how much of it is coming from the cross-sectional, the final estimate is coming from the cross-sectional versus the pre-post design. What he told me, I haven't seen all this data yet, is that in this particular data set, there's actually a lot of it is coming from the pre-post rather than the cross-sectional. So I still want to think about why that's happening, and how that method is operating to tell you how much is coming from which. And then I do think that and this goes to Ian's letter to the editor about Ebola vaccines and using the stepped wedge design, is I think it would be nice to see more guidance on the conditions under which we should avoid this design. So, I say that because I feel like this design has become very popular, and it's become popular more. It's being more touted because it's quote unquote an ethical design, and I find that a very strange argument. Because if you're in equipoise, you're in equipoise. If you're not in equipoise, say so and do a different thing. So here are some of the thoughts that I had about these designs. This is kind of the primary reason these are being touted now. And my feeling is think carefully about whether you think you're in equipoise or not. And if you're not in equipoise, fine. But then say that. Don't sort of pretend that this is an ethical way to do things. So it takes longer. Larry's been the one who's always said this to me. It takes quite a bit longer to get an answer in these sorts of designs than it does in an RCT. And so longer also means more costly. So I think you need to consider, when you're thinking about the ethics, it's not just who gets what and so on, but like how long does it take you to get your answer, and how long are you putting people at risk or burden in a study to get your answer. So I think that it's helpful when you have some sort of program that you really believe works, and but you can't roll it out all at once. And you can learn some things about that program by rolling it out in a randomized, staged way. So to me, this is the most compelling reason to do these sorts of designs. And I think the other is sort of politically or logistically, it won't be acceptable to do the standard randomized trial. But as we saw in our experience, we thought politically we could not do this randomized trial. But when we got to the second phase, it seemed like people were quite happy as long as you said, they were not totally happy, but they were accepting of it that they would get the stove a year later. I think this would make up for all the hassle of doing this stepped wedge thing. So I don't know what some of the other thoughts people might have about when to do this kind of study design or not, but my feeling is the primary sort of reason would be when you have something that you think works and you just can't roll it out all at once, and you can learn something by rolling it out in a randomized time frame. Okay, so just to tell you where are these stoves now. So this is this improved biomass stove, and I was there in January, and we were walking around in various villages and just asking people, are you still using the stove, etc. And most people said, oh, I've sold it for scrap, or I exchanged it for scrap, or here was one sitting on a garbage heap, outside, and you can see that it doesn't wear very well. So over a couple of years, these things start to rust. I will also say that the design of these, they've been designed very nicely in a lab in Colorado somewhere. And, that showed very nicely how they reduced the indoor air pollution, etc. And when you bring them out to this environment, these ones that have the two burners, the one heats quite nicely. The second burner doesn't heat that well. It's something not good about that design. So people would say, well, it doesn't really heat my food well. It takes too long to cook on these things. they just basically build they either kept the traditional stove or they had that. So I think some of the post-distribution high levels may well have been people cooking on both or having switched back to the traditional stove. So I think that these have a lot more to go. There's a lot more design to go before it's really going to be something that people will take up from a behavioral perspective. And in 2010 or something, Hillary Clinton made a big thing about these cook stoves. She went on, you could go and look. I just Googled Hillary Clinton cook stoves, and there, up came all these YouTube videos of her announcing the, Clean Cook Stove Alliance, and she's going to get these stoves to, everybody in India by, 2015 or whatever. And there was tremendous sort of optimism about the value of these stoves, and I think it was really premature in terms of even just thinking about the design of these stoves and whether they actually do what they're supposedly meant to do. So with that, I'll stop and just mention, obviously, that this was a big collaboration, and lots of people here in Nepal, and many students, and us, the Institute of Medicine at Tribhuvan University, and then our funding sources. So hopefully there's tons of data. Any students who want to try their hand in some of this, we'd be happy to share some of that with you. And thank you. Let's see if we have any. 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 Let's see if we have any.